Okay team, so in today's video we're going to be looking at blood pressure, thinking about what is blood pressure, how we measure it and how we would describe it. So first things first, what actually is blood pressure? Well, it's the pressure exerted by the blood on the arterial walls, and we express it as two values, systolic blood pressure and diastolic blood pressure. Now if we look at the image on the left, we can see that systolic blood pressure is expressed and it's a higher value, and diastolic blood pressure is a lower value. Reasons for this. Systolic blood pressure is the force exerted by blood on arterial walls when the ventricles contract, whereas the diastolic blood pressure is when the ventricles are relaxing. So there is a lower value for blood pressure when the ventricles are relaxing. And as you can see on the screen now, we have different values for different measurements of blood pressure. We can see that in green, the ideal value for systolic blood pressure is between 90 and 120, and diastolic pressure, the ideal values are between 60 and 80. So why is elevated blood pressure dangerous? Well, if we have high blood pressure, that can lead to damage to arteries. They become stiff over time, they can leak, they can rupture, and also the heart muscle itself can become tired because it has to work harder than it should have to, okay, because it's pumping blood against this increased pressure regularly. Okay, next thing we need to think about, how is blood pressure going to change when we move from rest to exercise? We also need to be able to describe what happens if exercise continues to increase in intensity. So if we look at the graph here, we can see that systolic pressure increases as exercise intensity increases. However, diastolic pressure remains relatively unchanged. Okay. As exercise intensity increases, systolic blood pressure also increases along with that. However, if steady state exercise is prolonged, systolic blood pressure can actually start to decrease. And this is due to dehydration and increased vasodilation in the working muscles. As we can see on this image here, the systolic blood pressure and how it reacts to different types of exercise, and diastolic blood pressure and how it reacts to different types of exercise. Key thing to note here is that diastolic blood pressure increases with isometric muscle contractions, or in the image, static exercise. Okay, now in this journal article here, it does talk about it in more detail, and I'll put that link in the description of the video below so you can read through that in your own time. Okay, so we're looking at the difference between squats and wall sits. So we've got isotonic muscle contractions in the squats and isometric or static muscular contractions with the wall sit. And we need to know how systolic and diastolic blood pressure are going to be different. Okay, so in summary, during dynamic exercise, we've already talked about this, systolic blood pressure will continue to increase along with exercise intensity, whereas diastolic pressure remains unchanged. With static exercise, however, or isometric, this increases systolic and diastolic blood pressure dramatically. Okay, now this is due to compression within the intramuscular arteries, which increases the resistance to blood flow within the muscle, and therefore increases both systolic and diastolic blood pressure. Okay, so to sum up the video, hopefully now we should be comfortable with being able to define the difference between systolic and diastolic blood pressure. We also should be able to analyze the difference between systolic and diastolic blood pressure between rest and during exercise. And we should also be able to describe how systolic and diastolic blood pressure responds to dynamic or isotonic and static exercises or isometric exercises. Okay guys, thanks very much. See you next time.